And I still don't know why my little thing flashes, but it's gonna keep flashing, I guess. All right, so today we're gonna look at some circles and how circle equations work and how we can manipulate or move circles around. So they want us to begin by investigating this y, or x equals y squared, and x squared plus y squared equals 25. So we're gonna work on that. I'm gonna flip the screen and we're gonna solve that baby for y, and then we can probably open up Desmos and see how those actually look and see if we can come up with a commonality of how circles work. Alright, so 224 has to do with our little circles. Make that a little bigger for you guys. So they wanted us to, what was it? Solve each equation for y and graph that equation. So the first one they gave us was x equals y squared, and then the second one they gave us was x squared plus y squared equals 25. Okay. So we can start with the one on the left, and if we want to solve it for y, what are we going to do? Take the square root of both sides. Okay. And when we take the square root of x, we know that we're going to get the positive and the negative square root of x. And if we take the square root of y squared, we know we're end up with just y. Because if we were to square 2, 2 times 2 is 4, but we can also do a negative 2, right? So a negative 2 times a negative 2 is 4. So anytime we take that square root, we're always going to get that positive and negative value. And then on the one on the right, if we want to solve that one for y, I think the first thing we should do is probably subtract x squared from both sides. Okay. And then now we got y squared equals 25 minus x squared. So now we're going to take the square root of both sides. So the square root of y squared is going to give us y, and then we're going to get that positive and negative value of 25 minus x squared. Right. Whoops, my bad. We no longer have y squared, right? When we square rooted the y squared, we just have y. So now that we got these two little guys, we can probably try and plug these into Desmos and see what we come up with. Right. So the first one we had was y equals the square root of x. So it gives us that little guy. All right. And what do you think is going to happen when we put the negative out front? It's going to flip it over the x-axis. Yep, exactly. So minus the square root of x. It gives us that little guy, right? So that positive is giving us that top portion, and the negative is giving us the bottom portion. So let's try and put in our second equation. We ended up getting y was the positive value of the square root of 25 minus x squared. Oh, he's cute. So what do you think is going to happen if we do the negative value of that? Yeah, 25 minus x squared. It gives us the bottom part. And what do we have? We have a nice little circle, a perfect circle, right? Yep. And then if we just kind of look at our little circle up here, Actually, I'm going to throw in the other one. So remember what the original function was? What was it? It was x squared. Whoops. Yep. Plus y squared equals 25. Right? All right. So the top, the bottom, and the whole thing. So let's see if we can come up with a little stuff on this one. So when it comes to circles, we always try to find the center of our circle. Right? So on this little circle that we have, where's our center at? At 0, 0, right? It's at a point like 0, 0. So we almost think of that. Remember like when it came to the parabolas and we had the HK, which was our vertex, and that was always a great point because we knew off of that vertex we had that symmetry. If you could find the vertex, you knew this side was going to match the other side, right? So the same thing kind of happens with the circle. You always want to find the center because that center is going to help you figure out some things. Circles will always have a thing called a radius, right? Anybody remember what a radius is? Yeah, you can think, yep. If you go all the way across a circle from one end to the next, like through the middle, through the center, it's the diameter, right? So the radius is from the center to any point that's on the circle, right? And if we look at our circle, do we know what the radius is? Yeah, it's 5, right? If I went from the center up to this point, we know that that's a distance of 5, right? If I went from the center, whoops, straight up, I know that that's a distance of 5, right? And actually, even if I went in from the center and I wanted to come out to any point, it's always going to be a distance of 5, right? Very cool. So I'm going to switch back real quick. Where's my... Oh, I lost it. Hold on. All right. So we'll just go to the next one. So we'll do some circle definitions. All right. So we kind of had that x squared plus y squared equals 25. Right? So all circles have a center. And when it comes to our center of our circle, just like on the vertex, we're going to refer to that as H and K. And then we always have a radius. What do you think we're going to use for a radius? R. Okay. And by definition, the radius is, or the distance from the center to any point on the circle. And if we, like our little cheesy, I can never draw circles, so we're going to use our imagination. Right. Perfectly drawn circle, right? What's a circle made up of? Like, what's that right there? Is that a point? And that's a point, and 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 a point. So a circle is just a whole bunch of points, and those points are just really close together, and it makes it look like a circle, right? So by definition, if I go from the center of the circle to any point on the circle, any point, it's going to have a distance of 5, right? No matter where I go. So if we think of our problem that we had up here, that x squared plus y squared equals 25, our center was at 0, 0, and our radius is a 5. So when it comes to the official little equation for a circle, we write it as x minus h squared plus y, I'm a dork today, y minus k squared equals r squared, right? And this h and k, just like when we wrote the graphing equation for our parabolas, hk was our vertex. So in a circle, guess what our hk is? The center, right? And then whatever it equals, that whole number, that's going to help us determine what our radius is. So if we took our original one, that x squared plus y squared equals 25, if we wanted to write it in graphing form, into the circle form, we would technically have what? X minus, what do you think our h is going to be? Yep, for our center, which was 0, right? Plus y minus, our k value for the center was 0. And what was our radius? Can we say our radius was 5 squared? So we don't even need a graphing calculator to tell us how to graph circles, right? So let's say we had x minus 3 squared plus y plus 7 squared equals 169. So to graph a circle, we need to know the center and we need to know the radius. Right? So this would be like x minus h squared plus y minus k squared equals r squared, right? So we know our center is hk. So in our problem, yep, our h is going to be 3, yep. And our k is going to be -7, right? It's always going to be like the opposite. Yep, yep. And then now we just need to figure out what our radius is, or r. What do you think r is going to be? These are equal, right? So r squared equals 169, so you got to take the square root of 169. Anybody know what the square root of 169 is? It's bigger than 12 but less than 14. It's 13, right? So then to graph it, we'd have our x and y, right? Our center is going to be at 3, -7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Right? So here's your center. And then your radius is 13, right? So from the center to any point on the circle is 13. So I think I'm gonna run out of room, but I'm just gonna count 13, right? Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then I'm going to count up 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to count over 13. I'm going to count down 13. And then I can draw. Okay, so I can't draw. We're just going to make it smaller. Move it over. Should have did this on a full screen. So we found our center was like at 3, 7, or 3, -7, and then you would count up 13, count over. See, I'm still off, right? And then you can draw a perfect little circle. And then if you wanted to check it, you could put it into Desmos. You think we're right? So our equation was x minus 3 squared plus, yep, what was it, y plus what, 7? Yep, thank you, squared, whoops, guess I didn't need the y equals there. Equals 169, right? And I'm just going to shrink this baby down a little bit. So we think that our center is at 3, -7. So let's see. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So right where my pointer is. I wish I could add onto Desmos. But right where my pointer is, and that's the center, right? And then if I go to the right, left, or anywhere, I should be 13, but going straight horizontally and vertically is easier to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Boom, right? If I go back from that spot, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I made it, right? Not too bad? All right. So going right back to where we said at the very beginning of this chapter, right? If we know how to graph those quadratics with h and k, that same thing applies to all these different equations. So the same thing even with a circle. Granted, with the circle, you have your x and your y on one side of the equal sign, but the same, oh, I guess it's going to be over here. All right. X and y are on the same side as the equation, but it still kind of works the same way, right? That h is how far to the left or right, the k is how far up and down, which gives you that center.